so today we're going to graph polynomials by hand, which means we're gonna do all this without a calculator. Okay, so we know how to graph them if there is no calculator available. So I know we went over these steps, so we're gonna go to step example 4. So it says to graph this function. Okay, and we're gonna do all of this without a calculator. So we're definitely gonna use some mental math today. Okay? Alright, so step 1 said to find the possible rational roots. Okay, that is our P over Q. That's what you guys wrote down last week. And then when you're finding the roots, remember what I said, if it's a 1 in front? Anything divided by 1 is going to be itself. So let's just write down the factors of 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. How many total roots are those?
8.
Good. So 8 total roots. So when you don't have a calculator, what you have to do is you have to test your roots from step 1 to find what your x-intercepts are. So before, when we had the calculator, we would use it to find the x-intercepts. Now, what we're going to do is use that synthetic division. And I usually just, I go down my list. Okay? If you're feeling daring, you can choose any one of those 8 on the list. So I just start with -1 to see if -1 is going to be a root. So I'm going to set up my synthetic division. So my coefficients are 1, 4, 1, -6. Okay, and how do I know if -1 is an x-intercept? What would happen? Yeah, the remainder would be 0. Very good. So this is -1, 3. 3 times -1 is -3, -2. This would be +2. Okay, so my remainder is not 0, which means this is not an x-intercept. Okay, that's okay. Let's go to the next one. So let's try 1. You would use your same coefficients. Okay, and hopefully we don't have to test all 8 before we find one. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 1 plus 5 is 6. This would be 6. Yay! Okay, so what this means is that 1 is an x-intercept. Okay, so remember, our goal here is to graph. So if 1 is an x-intercept, I've already found a point that I can put on my graph. My point would be 1, 0. Now, just like we've been doing before with synthetic division, okay, we did step 2 where we were testing the roots using synthetic division. But now we want to solve the quadratic equation from step 2, okay, to find all of the roots. All right, so let's do that. So this is my number, my x squared. Now, before, when we were finding the rational roots, we'd always use the quadratic formula. You could also try factoring in this case because you don't know how many of your roots are rational roots. So you found one of them, okay, but there could be more. So before I set the quadratic formula, I'm going to ask myself, are there 2 numbers that multiply to 6 but add to 5? Yeah, what are they? Yeah, so it's going to be a lot quicker for me to factor. Okay, maybe you want to do the quadratic formula. That is fine. You can decide. But for me, I ask myself that question. Are there 2 factors that multiply to 6 that add to 5? Because if they do, I can just set them equal to 0 and solve, right? Okay, so x would equal -2. X would equal -3. So look, I have 2 more x-intercepts. -2, 0, -3, 0. So now I already have 3 points that I can plot on my graph. Okay, and then if we look back at our steps, it says to find the points between the roots and the y-intercept. So to find the y-intercept, you guys remember how to do that? What can you plug in for x? 0. And really, just think about this. Okay, if you plug in x equals 0, what happens? This is 0 plus 0 plus 0 minus 6. Okay, so it is going to be your constant term. Okay, so your y-intercept is -6, and how would we plot that? Yeah, so 0, -6 is going to be the y-intercept. Okay, so what we're going to do is we're gonna start setting up our graph here. Okay, we'll do this together. Okay, so here's my y-axis. Here's my x-axis. And the first thing I'm going to do is just start plotting those points, okay? So I have 1, 0. So right here, 1, 0. And then this is going to be -2, 0. And then -3, 0. Oh, shoot. Did I plot -3, 0? No, I did not. So don't look at that. Just going to make that a little thicker. Okay, so I have 1, 0, -2, 0, -3, 0. Sure. And then we have the y-intercept, which is 0, -6. Okay, so there's -6. Okay, so what we're going to do next is we are going to find other points where we want to see what happens. And in order to do that, I am going to go to step 5 because I want us to recall some of the things we talked about last week. So step 5 is determining the end behavior based on the coefficient and the degree. So let's look at the degree. Okay, what's the degree of this one? 3, so it's odd, yep. And what does that mean? Good, the ends go in opposite directions. Ends go in opposite directions. Okay, so if you weren't here on Friday, that's one of the main things that we learned. Okay, so you'll catch up on that. And then the other thing is the leading coefficient. So what do we want to know about the leading coefficient? Yeah, if it's positive or negative. And this one is what? Positive. Yes. Okay, and remember it's specifically for the right side. Okay, so it goes up on the right. Okay, so we have these points here. We want to figure out what's happening to each end. Because right now, I don't know if this end is going up or if this end is going down. So to figure out what's happening, we have to look to the left. So if this is -3, how could I find out what's happening? Like whether this is going to be going up over here or whether it's going to be going down. How can I determine that?
Wouldn't it go down because they're going in opposite directions on the right side is going up, so the left would have to be going down?
Yeah, you can think of it exactly like that. You know that this is going to go up on the right, so this is going to have to go down. Absolutely. Good. And then if you wanted to know exactly what the point is, what could you do? Yes, you could. You could plug in -4 and see exactly what it is. Okay, so you could plug in -4, you could find that. Okay, but because we know it's going to be going up on this side, it has to go down on this side. So, again, we're drawing a sketch here. Oh, I'm going to use purple. Maybe I should use my pencil. Okay, so I'm just going to draw this going down. Okay, great. Okay, and then if you want, you could also draw that. I'm going to construct this like piece by piece so I can, I'm going to connect those two together. Okay, now, what we want to do is we want to see in between these what's happening. Okay, how high are we going to go to see where that is? What can I plug in to see what's happening in between these two? Like where the bend is. Do what?
-2.5.
Yes. Now it's going to be, again, because we're not using a calculator, it's going to be kind of hard to plug in the decimal to calculate the decimal. So can we write -2.5 as a fraction? Yeah, what would it be?
5/2.
Yeah, -5/2. Okay, this is going to be the most brain power we'll use all day, but we will go through this together. Okay, so this would be -5/2 cubed plus 4 times -5/2 squared. And then I'm just going to put -5/2. You could put plus -5/2 minus 6. Nope, not using that. Don't do it. It's good mental math practice for that. No calculator SAT. So -5 cubed, we know what that is, right? Because we studied our perfect cubes. What is it? 5 times 5 times 5. Yeah, 125. Okay, and 2 cubed is? Yay. All right, and then let's just do this. We can do the square part first. Over 4. Okay, and then -5/2 minus, I'll put 6/1. So when you multiply, well, there's a couple different things you could do here. You guys see how the 4s would cancel out? You could do that. Okay, you can also get a least common denominator. Yeah.
Since the, oh wait, never mind.
So we are going to want to add all these together. So I did make this 100/4 because what's going to be my LCD here? Or what's going to be the least common denominator? No, what's going to, so look at all the denominators. Remember, if you're combining fractions, you want them all to be the same, so what am I going to make all of them? No. Yeah, I'm going to make them all what? Somebody whispered. The whisper in the wind. What's your least common denominator? Yeah, it's 8, right? 4 times what is going to give you 8? 2, so you multiply the top and the bottom by 2. Okay? What do you multiply by 2 to get to 8? 4, so you multiply by 4/4. And then this one's a whole number, so you multiply by 8/8. Yeah, if you were to go lower, you'd have to divide both of them, and like 4 doesn't divide into there evenly, so it'll get messy. So this is 200/8 minus 20/8 minus 48/8. All you have to do now is combine the tops. So what's -125 plus 200? 75. 75 minus 20 is 55. And then 55 minus 48 is? Yeah, so it's just 7/8. So that means in between -3 and -2, it's almost 1 right here. So let's plot that point, and then look. Now we have the curve in our graph. Okay? So we're really almost there. We could also figure out what happens at -1. which is going to be a lot quicker, right? Because can't we do that part, a lot of it in our head? Because what's negative 1 to the third? Negative 1. And then it's plus 4 times negative 1 squared. So negative 1 squared is 1. 1 times 4 is 4. And then it's plus x, so that would be plus negative 1 minus 6. So, like I said, a lot of that's just your mental math. So negative 1 plus 4 is 3. 3 minus 1 is 2. 2 minus 6 is negative 4. So then let's plot that. So 1, 2, 3, 4. Okay, so now this is going to be smooth here. And then we know that on this side it has to go up, so I can curve this here. And there you go. There's your polynomial. Whoosh, whoosh, whoosh. Yeah. And when you have a degree 3, the most that you'll have is 2 turning points. So this is 1 turn, this is the second turn. Okay, and that's how you can graph it without a calculator. Now we're going to go back to our calculator, and we're going to talk about the local maxima and the local minima. Okay, so if we're talking about something that's a local, what does that mean? Okay, yeah, so like what are some things local to where we are now? Okay, yes. Okay, so there are things that are in the area, right? So a local max or a local min is going to be the highest or the lowest point in a certain area of the graph. Okay, the highest or lowest point in the certain area of the graph. Okay, so the one that we just graphed, that one has a local maxima or minima, because if you look at this graph here, okay, in this area, this is the highest point. But is that the highest point of the graph? No, because this guy is going up to infinity. Sorry, this has been happening. And then here, this is the lowest point, okay, in this area, but it's not the lowest point overall because that one keeps going down. Okay, so that's how it's different than a local max or a min, because a maximum or a minimum is the highest or the lowest point of the entire graph. Do you guys remember what the graphs looked like when we had those? Yeah, the quadratic. That's when you had the parabola, right? This was the lowest point of the entire graph. Or this was the highest point in the entire graph. Okay, so that's different than when you have the different curves here. Okay, this is the highest in this area, this is the lowest in this area. Okay. Now every turning point, which is a turning point is just when it changes directions. Okay, every turning point on a graph is going to correspond to a local maximum or minimum. And we are going to use our graphing calculators to find those. We are going to be using the max and the minimum function, which do you guys remember where to go to on your calculator to find that? Yeah, great. You go to the second button, and then you hit the trace button, because there's a little calc above it. So you're calculating that value. Now, example 2 says to graph it on a calculator and then estimate the local maxima and minima. So we are going to be rounding. Remember, do you guys remember what part of the coordinate is the local maxima or minima? Yeah, it is. Okay, so it is the y coordinate, so you're not going to put the x down. Okay, when they're asking for the local maxima or minima, it's the y. Okay, so we'll go ahead and graph A together. So we have 2x to the third minus 18x plus 1. And then you always want to, if you want to go to your standard window, it's zoom 6. But then, what's the problem here? We can't see the curves. Okay, so I can see, like, based on what I know about graphs, right, I can see this is going to go up and then curve back down. So I need to go higher on the y, and I need to go lower on the y. I don't need to change my axis at all. So let's go to our window. Let's figure this out together. Okay, so the x's, we don't have to change those. What do you guys want to go down to for the y's? How about, let's go to 30. And 30. Now, if you change that, change your scale. Go by 2s, go by 3s. Ooh, doesn't that look nice? Alright, so now let's find the local maxima and minima, okay? So you just, when you're adjusting, just adjust the min and the max on your y's. And then I adjusted the scale so that the points aren't so close together. Okay, and then I'm going to go to second calc. I'm going to look at the maximum first. Okay, so for the maximum, okay, I'm going to arrow over, and it's going to ask me left bound. So I try to get to the max. And remember, what you're telling it is look for the highest point in between these two bounds that you're setting here. Okay, and then I'm going to try to get right at the top. Okay, so it's only the y. So when you write this out, you can write the local max, and we'll round to 3 decimal places. So 21.785. Notice that there are 2 turning points here. So you'll have 2. Sometimes they might both be local maxes. Sometimes they might both be local mins. It just depends. And then I want you to find the local min for this one. And then do part B. Okay, so you find the local min. You find the local max. If you guys don't have your graphing calculator, come trade me for something, and I'll help you. Okay? Alright, so for part A, Dylan, what did you get for the local minimum? Yep, and then I kept it to the 3 decimal places. It's just 785. Okay. And then, yeah, for part B, it is a little less curvy, but you still have these 2 turning points. So again, when you're calculating your maximum, what you're telling the calculator is find the highest point between whatever 2 points, whatever 2 bounds you give it. Okay, so if you tell it where to look, it's going to give you the highest point in between the 2 areas that you select. So your local max here should be negative 1.911. Okay, your local min, we have to go back to calc to do the minimum. And again, this just happened to have 2 of them. This is for the minimum, so now I'm going to go low. Okay, so I'm going to say find the lowest point between here and here. And then I'm going to guess, there we go. Okay, so I got negative, if I'm rounding to the 3rd decimal place, 0.08, and then this 8 is going to be rounded up to a 9 by that 6. Okay? If you had, let's see if I change this to a x to the 4th. Okay? If you have something that looks like, oh, that looks not good. I just want to show you what it would look like if you have like 2 curves. Okay, so see how you have 2 local mins here and then 1 local max? That could happen as well. Okay, so you could have 2 local maxes. You could have 2 local minimums. Okay, we are going to do some graphing for 3-8 today. And so if you have like the W, you have 2 local mins and 1 local max. Okay? Alright, so let's get out our next thing.